My name's Derek Parnell. I'm the field engineer for the Canadian Tower. In order for us to create a stable base so that we could have vertical construction, we had to start drilling down into bedrock to create that stable base for the tower. So we drilled 6 drilled shafts per tower leg, capped that all off with a footing, which created a stable base so that we could build the tower legs as they are seen today. Each drilled shaft is about 36 meters deep, and they have a rock socket of about 4.5 meters into bedrock, and they contain 325 cubic meters of concrete and are filled with rebar. The base of the tower legs was constructed into 3 lifts. The first lift was 1,000 cubic meters, which took us about 34 hours to pour. Then the second lift was about 600 cubic meters, which took us about 24 hours to pour. And the third lift was 320 cubic meters, took us about 8 to 10 hours to pour. The footings on each tower leg are connected by what we call a tie beam. It's a concrete structure which holds the post-tensioning cables that run all the way from our north tower to the south tower, and we stress them just to lock the tower in place. Right now the tower legs are sitting about 460 feet tall. We started construction in February of 2021, so it's taken us about a year to get to where we are right now. Total across both tower legs, the total concrete used was about 7,000 cubic meters. We actually pump it from the ground. We have a stationary pump at the base of the elevator, and we run our concrete line up the elevator mast and through a hydraulic placing arm. Rebar, we used around 3,000 tons of rebar total for the tower legs. As we know, access for a structure like this is kind of awkward, so they came up with this jump form system, which gave us access to do concrete, rebar, formwork, and it's a self-climbing system. We have a temporary elevator actually attached to the system from the ground up. We had a catwalk that linked the two together, but now obviously you can see the towers are very close together, so we just created a small little platform. Tower crane was used just to service both tower legs to lift materials such as rebar into place. The legs are connected through what we call the transition area, and essentially through a complicated process, we have the 2 jump form systems and we merge them to become one. After we merge them, we're able to pour a concrete soffit slab that links the two, and then we pour 2 solid lifts above, which then kind of creates that wishbone at the top, and where we can continue on with the tower head. Here we're standing at the top of the south tower on top of lift 229, top of the tower leg, where we have began work on creating the transition area. Behind me, you'll see where we will start to create a soffit slab that will join the 2 tower legs. And then above where we are here, we'll have 2 solid pours. So there will be a concrete, the soffit slab is essentially a wide beam that links the 2 tower legs. So after the tower legs are completed, we're able to start installing our steel anchor boxes, which house the anchorages for our cable stays, which are strung from the top of the tower down to the road deck. So the tower head is going to consist of the anchor box, which is then surrounded by concrete. It'll be hollow on the inside, so it allows access up and down as well. Once we have completed the transition area here and we've linked the 2 tower legs, we'll be able to remove our upper strut. We no longer need that temporary support because the tower legs are permanently tied together at that point. Because of the inclination of the tower legs, gravity wanted to pull them in, and we needed temporary supports just in order to push them back out into the location that they needed to be. So once we had a lower strut, and then once we jumped further up the tower, we were able to put in an upper strut and remove the lower strut. Now we're at this point where we can join the 2 tower legs together permanently, and at that point we no longer need the upper strut and we can remove that. It's really a once-in-a-lifetime experience getting to work on a project like this. It's especially as my first job, it's going to be a tough one to beat, that's for sure.